Hi everybody, welcome back. Today we're going to review the binomial distribution. Now recall what a binomial is. A binomial is basically an event in which one of two things can happen. For example, if you flip a coin, it's either going to be a head or it's going to be a tail, but it can't be both. So therefore the events are mutually exclusive because it has to be one or the other. It's a distribution that's got a fixed number of trials. So for example, if you want to toss a coin 10 times, you'll have 10 different trials, and they're all independent of each other. So if you flip a coin now, and then you flip a second coin, those outcomes are all independent of one another. But the event itself, when you flip any particular coin, is mutually exclusive because they cannot share and do not share any common outcomes. So for example, you want to find the probability of 6 heads in 10 coin tosses. So we have a formula for that, which is probability of capital X equals little x, and that's going to be n choose x times p of x times 1 minus p to the n minus x. Now, your p is the probability of a success, so 1 minus p would be the probability of a failure. That's the complement. N is going to be the number of trials you have, and in this particular example we have 10 coin tosses, so you have 10 trials. And X is simply a subset of those, so we want to find a probability of 6 heads. So 6 would be our X, or our subset. Now I plug my data in. So I have 10 choose 6 times the probability, which is 0.5. Whether it's a head or a tail, probability is going to be, but we have to raise that to the power. So it's going to be raised to the 6th power, because x is 6 times 1 minus 0.5 to the 10 minus 6. I'm plugging in my n, which is 10, and then minus 6 for that exponent. Now 10 choose 6 can be written out formally and officially as 10 factorial over 6 factorial. 4 factorial, because that's 10 minus 6, and then times 0.5 to the 6th, and then 1 minus 0.5 to the 4th. Now in the calculator you can simplify using the factorial notation, and that will equal to 10 times 0.015625, and then 0.5 to the 4th is going to be 0.0625. After you compute all of those, it's approximately equal to 0.2051. And this number right here, that's the probability of getting 6 heads in 10 coin tosses. Let me write down, this is the probability of 6 heads in 10 coin tosses. Now, there's another way you can do this on the calculator using an advanced function. So on the TI 8384, you're going to click on second bars, which is next to the clear button. It's 1 over. So you do the blue button, second bars. So I'll write second bars. And then you're going to click on distribution, and you're going to pick letter A. Letter A, when you scroll down, is going to be the Binomial Pdf. And it requires you to enter your data in the following format. It wants your n, followed by the probability, followed by the x. So in this case, you go to get the Binomial Pdf, and you enter 10, 0.5, 6. And when you hit enter, you'll get approximately 0.2051. which is exactly the same as we did by doing it the long way, the manual method by hand. So what we have done is just reviewed the binomial distribution, and we have computed the probability of finding 6 heads or getting 6 heads in 10 coin tosses. I hope this review has been helpful. Thanks.